Hello YouTube, this is Dazza the Cameraman. Today is Saturday, May 20th, 2017, New Zealand time, and we're taking a look at one of the recent videos by WSO, Steve Olson. Can't you see the sun is off? Let's have a listen to what Steve has to say in this latest video.
Hi everybody, it's Steve Olson. It is May 19th, 2017, and oh my God, are things busy right now. Unbelievable stuff going on. Stuff you can see with your naked eye. Stuff that you can see with your naked eye. And here I am right now talking about one of those pieces of evidence. Now, one of the things that everybody's been noticing is that the sun has been too far north for us to be so close to the summer solstice. And I'd have to agree with this. I took a measurement last night. This is from a subscriber. When that little red dot that I'm showing you there, that's where the sun set in their area in the Midwest. I'm a little bit further up in western Minnesota right now. Our sunset last night was at 328 degrees northwest. Again, it seems to vary in various places. And we're all noticing it, guys. This is not something that just I'm bringing up. I get at least 30 emails a day, literally, of people that are saying the sun is not in the right place. Have you noticed that too? Have you noticed that the sun is too far north, too far south on any given day? Especially those of you that have lived in places for a long time and know where the sun should be. So guys, let's do an assignment. Let's do this together. Send me your emails tonight, just for May 19th. Send me an email if you think of it, if you've got a compass. Go out and look at the sun. Point your telescope or your compass at where the sun is, okay? And then it will show you, then basically, wherever you point your telescope, you'll be off by, probably by whatever the numbers are, just write it down. So, for example, if the sun is at 345 degrees, you set your compass up so it's pointing north, and then you point the little line towards the sun, and that will show that will show where the sun is relative to north, right? So if you know how to do that, send me how far off the sun is today, and let's see if we can do a little experiment amongst ourselves to figure out how bad is the sun anyway.
So let's take Steve up on his assignment and let's all get involved in this, but let's make sure that we do it properly. Now, first of all, there's a couple of things that we need to understand, and the first thing is that magnetic compasses are not always reliable for a couple of good reasons. The first one is magnetic declination, which means that depending on your location around the world, true north is going to be different to magnetic north by, for example, here in New Zealand where I live, by approximately 21 degrees. So in other words, my magnetic north is 21 degrees different to true north. So I have to factor that in when I'm using a magnetic compass. The other way to do it is to check the position of true north by using the shadow cast by the sun when the sun is actually at solar noon. Then you can check that against your magnetic north to work out your magnetic declination. The second reason, of course, is that magnetic compasses, being magnetic, are also affected by nearby metal objects. So if the compass is not being used correctly, then the magnetic reading is going to be incorrect. But let's skip right back to the very beginning of this video by WSO, and there's a little clue here that we can use to actually do this experiment properly.
Facing northeast, I believe, and the sun is in the southwest.
Right, so let's use this little video clip as an example of how this could be done properly by using Google Maps or Google Earth. Going out, finding a location that anybody can access on Google Maps or Google Earth in the street view, and film from that location the sun setting or the sun rising. And then people can go to Google Earth for that location, find the filming location, and check the angles for where the sun was shown setting or rising, and check the angle, the true angle, not the magnetic angle, using Google Earth. That will give us a more accurate idea of what's actually going on with the sun. Now there's something else that needs to be cleared up at this point, and that is that many people think that the sun rises due east and sets due west. Well, that of course is only true twice every year at the equinox. So we're talking about round about the 21st or 22nd of March and round about the 21st or 22nd of September of each year, when the sun will rise due east and will set due west. Only happens twice a year, and in between those times the position of the sun on the horizon drifts along the horizon because of the seasons. So at midsummer you've got the summer solstice, and midwinter you've got the winter solstice, and the sun is going to be to the extreme point to the north along the horizon or to the extreme point along the south to the horizon, depending which season you're in. Now here we are looking at suncalc.org, and I've set the location to Minnesota. The date is 20th of May, which you can see here on the left hand side, and I've clicked on the sunset time, which is 2052, and this shows the position of the sun. I can use this slider here as well to change the time. So here is sunrise at 5:40 a.m. and we've got solar noon, which is at that point there, which is at 13:16 or 1:16 p.m. That's the time when you'd want to check the shadow cast by the midday sun if you were going to calibrate your magnetic compass against true north. Check the shadow cast by a vertical wall, something like that, something that's not at an angle but perpendicular to the ground. Check the shadow against what you see with your magnetic compass for magnetic north. And then, of course, as we go through to sunset, which is at 2052, or I can just click on the time there and it'll snap into place. So that tells me that the azimuth, or the position of the sun on the horizon, will be at almost 301 degrees. Now that's true reading, not magnetic reading. Now I did check the magnetic declination for Minnesota, because Steve Olson says that he's in Minnesota, and according to this the magnetic declination is less than 1 degree. So there's not a big problem there. But if Steve is going to do this properly, then he needs to do it properly, okay? And as I say, the best way to actually do this is to film from a location that is easy for everybody to access through Google Earth or Google Maps, and we can check the position of the setting sun on the horizon using visible landmarks in Google Earth, Google Maps. And you may remember that we did this over a year ago as part of my Flat Earth Equinox Challenge, where we had 9 different people went out and they filmed either the sunrise or the sunset from a location that was easy verifiable in Google Earth or Google Maps. And we confirmed that the sun was actually rising due east and setting due west on the equinox. Now let's just carry on with Steve's video, and we'll look at a couple of other things that he brings up in the video.
Here's some photographs that we took today, some imagery that we took from the All Skycam network. And what you're going to see here is this is the kind of manifestation that we saw maybe a year ago in the southern hemispheres. Now we're seeing it in every northern hemisphere too. This big, red, ugly looking refraction. And I think it's a reflection off the sky is what I think it is, because it doesn't show up on the... But anyway, point being is it's reflecting something up there. Now look at it, rotates. You can actually see it rotating. Now you cannot tell me that that's any kind of an anomaly other than it's a reflection or refraction of an object that's up there.
Really, Steve? Well, you know, this is the same tired old stuff that we've been hearing from you for, what, nearly 2 years now, is it? Let's have a look. Here is the WSO channel, and let's go to the oldest videos on the WSO channel, and I've looked at this before in some of my previous videos. This is the earliest video, the oldest video on Steve Olson's channel that's available to look at now. Let's have a look at this and see what date it was uploaded. This was uploaded on December 15, 2015. Weird planet in southern hemisphere. Don't look away. Holy Lord, he says. And what do we see? Let's have a listen to this video.
My wife and I have been watching the skies through the various all sky cams for the last couple of days. If you look at my yesterday's video, when I first started picking up this activity, I thought it was for sure going to be a lens flare or some other anomaly. But instead what we find is a planet floating under the Earth. This is via Savannah Skies, Australia rather. The next cam, it's just starting to come into the picture, but in a different light because it's in a different location of Australia. And you can go look up these locations, but again, it's visible both in the horizontal and the kind of vertical view.
So we see the same old thing that we were being presented with back in December 2015, and of course on other YouTube channels we've seen the same all-sky cameras that go back years and years, and we see the same thing day after day, week after week, month after month, and year after year. And of course there's an important point that I've pointed out before, and I'll point it out again as we look at this video. I'll just mute this as I talk. Watch the motion of the supposed object as it crosses the sky. You've got the sun going in one direction from left to right, and you've got this pink object, planet, anomaly, reflection, whatever you want to call it, going in the opposite direction. Well, that presents a problem to start with, because the only reason that the sun appears to be traveling from left to right across the sky, or from east to west, is because the Earth is rotating on its axis from west to east at 15 degrees per hour. Of course, the Earth makes one rotation every 24 hours. If we divide 360 degrees by 24 hours, we get 15 degrees per hour. So the only reason that the sun and the stars and the moon, which does have its own rotation as it orbits around the Earth, the only reason that they appear to be moving across the sky from east to west is because the Earth is rotating from west to east. So if there was an object, a large object out there in space, then it would also appear to be moving across our sky from east to west as the Earth rotates from west to east. So obviously you can't have an object which is far off in space moving in the opposite direction to the rotation of the Earth. The only way that that could ever happen is if the object was in very close Earth orbit and was orbiting the Earth, which is clearly not the case. Even the moon, which is orbiting the Earth and is actually traveling across the sky in the opposite direction to the apparent rotation of the stars, moves so slowly because it takes approximately 1 month to orbit the Earth, also appears to move across the sky from east to west. So this makes a nonsense of the claim that this is any object or reflection or anything. In fact, what it is indeed a reflection. It's a reflection of the sun within the lens system, within the camera housing or the lenses. It is a lens flare. And in fact, we have seen this object. If I spent more time on this, I could show you the lens flare actually inside the camera housing, like down here or even on top of the dome here, which proves that it's not even an object in sky. Steve Olson knows this, but he continues to trot out this nonsense. Now, he was in a hangout yesterday, and he was making sounds about, fronting up for a hangout and all that sort of thing. This was on another channel, and I said, yeah, you won't front up to a hangout with me, will you, Steve Olson? And although he talked about love and being polite, all he could do was criticize the screeching sound of my voice, as he put it. He says he can't tolerate the sound of my voice. Well, I know the real reason that you won't front up to me, Steve, is because you know that your claims, such as these ones, will not stand up to scrutiny. Now, I've always said that I will meet anybody halfway who is prepared to meet me halfway, and I will always treat guests with respect on my hangouts if they are prepared to meet me halfway to discuss their claims. I did that with Scott Cohn on the original hangout that I held with him last year, along with Astronomy Live. I treated him with respect, and he left the hangout saying, thank you, you treated me like a gentleman. And I still commit to treat anybody who will meet me halfway with respect. So Steve Olson, I challenge you to meet me in a hangout. Come along, let's discuss your claims, and let's try and get to the truth of what you're saying on these things. So just going back to this challenge about the sun setting in the wrong place, according to Steve Olson, Let's do your observations, film them from locations where we can confirm that using Street View or Google Earth, and let's see what the video actually shows us. This is Dazza the cameraman. Thank you for watching.